Lesson 3.2 takes the first lesson, so all those different types of angles and lines we learned about, and kind of just goes a little bit more specific or a little bit more narrowed. So to this lesson is going to focus really on what happens when your lines are parallel, okay? Now, we're going to be looking at 4 of these, but remember as we talked about yesterday or in the previous lesson, they consider this to be consecutive. Okay, so if you have like a different color or something like that, I want you to kind of take and I want you to draw like a nice dark line almost like right here. Sorry, I kind of went off my sticky note page here. Okay, because the top 3 are very similar, and then this bottom category kind of stands on its own. So I just want to make sure you kind of have that distinction there. Now, if we're in class, which some of you might have been absent, maybe you're quarantined, whatever the case may be, in class we're going to do a little activity where we're going to do some measuring. But since we're not, together and you're watching this at a different time, you're just going to have to watch mine. So I'm going to start with parallel lines. So I just have a little pack of sticky notes here, and I'm just going to draw a little bit of a line on this side and a little bit of a line on this side. Okay, so here are my parallel lines, kind of far apart. That's okay. Those are my parallel lines. Now, it says, if 2 parallel lines are cut by a transversal. So I'm going to take a different pack of sticky notes. So see, I have the 2 packs here. Okay, we're going to take a different pack of sticky notes, and I'm going to draw in a transversal. Now, I don't necessarily want the transversal to be perpendicular because that's just going to make them all 90. So it doesn't matter what angle I draw this at, but I'm just going to kind of tilt it here, and I'm drawing a line in. And so this is my transversal, and these are my parallel lines. Okay? Now, all 4 of these statements start with the same beginning. If 2 parallel lines are cut by a transversal. If 2 parallel lines are cut by a transversal. So every single one of these all start the same. So it's sort of like, if the lines are parallel, then what do you know? Okay, so we're looking at corresponding. This would be corresponding, that angle 1 would be corresponding to 2. And if you look at those 2 angles, because the lines are parallel, these 2 angles would be congruent. And in class, we would be measuring these to kind of make sure of that. And I would be asking you, what did you get for your angles? Okay, but because we're not together, you just have to trust me here. So if the lines are parallel, then corresponding angles are congruent. All right, let's look at alternate. So I'm just going to kind of erase this. This is alternate interior. So I'm going to erase this number 1. My eraser's not the best. Here we go, number 1. And so 2 would be an alternate right here. Well, wait a minute. Can't you tell these are vertical? Well, then if this was equal here, then wouldn't these 2 be equal? And then they'd be equal again, right? So if you have the parallel lines, alternate interior are also congruent. So we say if the lines are parallel, then alternate interior angles are also congruent. Well, let's look at exterior. So let's go back with our 1 right here. So if I can erase that, let me grab a better eraser. So if that was our angle 1, then an alternate exterior would be right here. Well, wait a minute. Isn't that vertical again? Okay, so notice if 1 was corresponding to here, this is vertical. So yeah, they would be equal. So once again, if we have parallel lines, then alternate exterior angles, are also congruent. All right, now we got to be careful because remember, I drew this line here. We're talking about same side. So we're going to do consecutive interior. So I'm going to erase these. Okay, let's say we put a 1 right here. That one doesn't have any lead. We put a 1 right here. If this is 1, same side or consecutive would be here. Now notice these are vertical, but these are a linear pair. Okay, so if you actually add these together, I mean, it doesn't have to be this way, but in my diagram right now, this looks like an acute and this looks obtuse. But I promise you, and if we're in class, we're going to be doing this. We're going to be measuring these. But if you add these two together, they will always be supplementary. Okay? So if you have parallel lines, then, and I don't care how you want to write this, you can either do consecutive interior angles or you can say same side interior angles are supplements. So you just have to remember that they add to 180. Now, I know it's not listed on here because, again, they use the word consecutive, but this also does hold true with same side exterior angles. So if you have same side exterior, as long as your lines are parallel, then same side exterior angles are also supplements. It also works. But once again, because your book uses the word consecutive, that's why they're not doing this. Now, we do again use some abbreviations. I want you to notice that these are theorems. In the previous lesson, we had some postulates. The difference between that is a postulate is something you assume, and a theorem is something you can prove. So because I could get out an actual protractor, which I just apologize, I'm at home and I don't have a protractor at home here, but if I could get out a protractor, I could measure these to prove to you that they're parallel, or that they're the same. So that's why these are called theorems. So many times the abbreviation that we use for this is corresponding angles theorem. Now the only thing different from yesterday's lesson, so I guess it's on the other side of my paper here, so corresponding, do you notice how it doesn't have the T? That's because if we look at some of these, the lines may not be parallel. Now 10 and 14, the lines surely look parallel, but because there's no marks on here, we don't know for sure. So on this particular lesson, we're going to be dealing with parallel lines. Therefore, we're going to be using the theorems. So that's all the difference that the T means. So you would call these alternate interior, just like the previous lesson, only now we use the theorem. And we're going to do alternate exterior with the theorem. And we're going to do, I'm going to call this same side interior, or if you want to call it consecutive interior angles, you can. But now we're saying theorem. So if you just kind of quickly glance through your pages for today, you'll notice that they have some type of a parallel mark on them. If you look at the problems from yesterday, they don't have the parallel marks. Now sometimes they, again, look parallel, but yesterday they really were only using parallel when they were talking about more of the three-dimensional or the real-life application. So down here, they just want us to use the diagram and see if we can come up with the answer, and then if we can state the reason. And stating the reason would actually be like one of these choices up here, like how do you know? So I'm going to look at angle 4, and I'm going to be looking at this going, well, I know it's 120, but now I have to say why. So it's 120 because those are vertical angle theorem. Remember, the theorem is what allows you to be more specific. Okay, let's look at angle 5. Angle 5 to this 120, those are going to be the same. And you should be saying, well, they're corresponding. Sometimes you almost do the justification before you do the answer. So if you want to write the justification first, you could. So for instance, let's do number 3. 3 is 3. If I look at number 3, I'm looking at those going, what are they? Well, those are a linear pair. So linear pair, and then it's a postulate. If you use the theorem, that's okay, but Euclid called it a postulate, so that's the only really difference. Now you got to be careful because linear pairs are supplements, so these have to total 180, which means this must be 60. So again, I'm just using all of my knowledge to come up with the answer here. All right, number 7. If you look at 7, 7 doesn't have a true relationship with the 120. But 7 has a relationship with some of these other angles. So if we were together, I would say to you, which one do you want to use? Do you want to use 2? Do you want to use 4? Do you want to use 3? You can use any one of them. But I'm going to use 3 since we just did the answer. So this is a 60. So if I look at that now, angle 3 and angle 7, those are corresponding. So because they're corresponding, I would say 60 degrees. Now, some of you might use 2. 2 was a linear pair, so this would also be 60, but it's alternate interior. So you might say alternate interior theorem, and then you would say 60. No matter what, you're still going to say 60, but your justification might be different. So I'm going to kind of put like a little star by this one. That one has a few different justifications, but only 1 degree, okay? So if you take a look at the next page, page 5, notice now they're just trying to give you some to solve for. I believe on yours, this is whited out, and so is this, so I apologize on my copy here. Mine was just the original. They just want you to figure out the value of x. Notice once again, you have these parallel marks. So if I look at this angle where x is, I want something to go with it. I want it to be a name, like vertical, linear pair, but it doesn't really go with 115. So I have to either decide, do I either want to do vertical, so I want to do this as vertical, or do I want to do this as a linear pair? So if I take 180 minus 115, I get 65. You are going to have to decide which one do you want to pair this with, because the work here would be different. So if we were in class, I would pick on one of you and I'd say, which one do you want to use? And somebody would say, I want to use the 165 or the 115. But because I'm all alone here, all by myself, I'm going to use the 65 for now. And then I'll show you the setup on the other one. So if I use the 65, these are corresponding. Now you don't have to tell me that, but I'm just writing it down so you understand my thought process here. Corresponding angles are congruent. So you're going to go 65 is equal to x plus 5. And then you're just going to simply solve it. And you're done. Now, what if you would have said, no, I wanted the 115. I wanted this one. How am I going to get the same answer? Well, if we use that piece, then these angles are same side interior angles, which means they add to be supplementary. So you're going to have to add them together. So if you add on the right here, you're going to get 120, and then you're going to solve it. So when you subtract the 120 off, you see how you get the same answer. So remember, sometimes there's different things to do, and sometimes there's only one. So if you look at number 6, I'm not saying I couldn't do a linear pair, or I could do vertical, but right now, the way these are sitting, these are same side exterior. Now your book would not show it this way because it doesn't use same side exterior, because it only uses consecutive. So if this was your book would be going 180 minus 136, and it would be getting this to be 44, and then it would use corresponding. So again, I don't care which one you use. You just have to decide. So I might use corresponding here now that I know this. So corresponding would make them equal, like that. But if I use same side, that makes them supplementary. I promise you, you get the same answer. It's just all a matter of how you want to work this out. So to me, it seems like that side would be a little easier. 44 minus 9. Divide by 7. And I'm done. But if you want to do this side, we can. So I get 145 if I add those together. And then if I subtract the 145, I would get x to be 5. See how I get the same answer? So they're not asking you to justify. Notice it just says solve. So it's ultimately up to you. So why don't you pause it here and see if you can do number 7. Okay, hopefully you paused it. Now number 7 to me is pretty straightforward. Those are alternate interior. So if we use alternate interior, we just set them equal. So I don't know, for me, I wouldn't see doing like a linear pair and trying to complicate it more. I would just probably use it the way it is. So I would move the 55 over, and then I would divide, and then that would be my answer. Okay? All right, we just have, I think, two more problems? 2 more problems to go here. Sorry. Yes, okay. I just want to make sure how many I had left here. All right, so in this one, they're just trying to give you a little application. In Geometry B, we do quite a bit of work with this kind of stuff, and we make them a little harder. So this is just kind of like an introduction to a more difficult problem. But it says, when sunlight enters a drop of rain, different colors of light leave the drop at different angles. The process is what makes a rainbow. So again, they're just trying to kind of give you an idea. For violet light, the measure of angle 2 is 40. So this would be a 40-degree angle right there on your picture. It says, make a conclusion about angle 1. Well, if we look at this, it's really hard to see maybe on my projection. So look at your paper, or this is from the textbook so you can look. There's a parallel mark right here and here, which means these lines are parallel, which makes this a transversal. And so if you look where angle 2 is and you look where angle 1 is, can you tell that those are alternates? And so do you notice I'm almost doing the reason before I do the answer? Sometimes that happens. You're like, well, oh, I know what kind of angles these are, therefore I know the answer. So because these are alternates, I can say that angle 1 is also 40. But if I didn't notice these parallel marks, which again, they are kind of difficult to see, but there are parallel marks right there. If I don't have those parallel marks, then I would not be able to make this justification. So I really, really need to notice those, okay? All right, the last one again is just trying to give you just make the problems a little bit harder. Notice once again, you have those parallel marks. And so they want you to find the value of X and Y. You can really do whichever one you want first, but I guess my eyes are jumping right to the X. 1, I guess it comes first in the alphabet. But if you notice, if you look at what those are, again, we have alternate, sorry, one of my pencils doesn't have lead, alternate interior. And with alternate interior, they're going to be equal. So we have 4x is equal to 52. So I know this angle is 52. I know that. But they're asking me for the value of x. They're not asking me for the value of the angle. So I just have to divide off the 4. So 52 divided by 4, I get 13. Okay, so now I have x, and now I have to get y. So here's my y, but I got to be careful because this angle does not touch the parallel. So I got to be careful in that, okay? So I really got to think about what I'm going to do here in order to get that answer. So what I'm noticing is this. You see this is 90? If these lines are parallel, doesn't that mean, sorry, I keep grabbing the wrong pencil. Doesn't that mean that these two together would also be 90? Okay, so right now I'm trying to solve it for y. Okay, so I'm just trying to solve it for y. So I'm thinking that these two together, so the lower plus the upper together have to be 90. That's kind of my thought. If this is 52, wasn't this 52? Or do you want me to go 4 times 13? Oops, I forgot to hit enter. It's 52. So can I just get rid of this and say this is 52? So if I add these together, so if I do 3y plus 2 plus 52, it totals 90. Notice I only have one variable. So now I just have to solve. So 3y plus 54 is equal to 90. I'm just going to subtract off my 54. And then I'm going to divide by 3. And now I've got my y. So notice that one didn't really use maybe a lot of like alternate. It kind of used the idea that this is 90 and then these are same side. So I guess it's kind of using same side interior. I'm kind of used like a combination of that to get to my answer. And sometimes that's what you have to do. Sometimes you have to use lots of different pieces of information to get to your final answer. But that concludes the second lesson.